Example 3.2. A. In example 3.1, the electron drift speed is estimated to be only a few millimeter per second for currents in the range of a few amperes. How then is current established almost the instant a circuit is closed? Because as soon as we close the circuit, the electric field is established in the conductor instantaneously. The speed of the electric field of propagation, that is equal to speed of light, and therefore instantly the local electrons are drifted under the effect of it and the current is constituted. Clear? B. Each, sorry, the electron drift arises due to the force experienced by electrons in the electric field inside the conductor. But force should cause acceleration. Why then do the electron acquires a steady average drift speed? Because when free electrons experience the force and are accelerated, then during their accelerated motion, it collide with another electron as well as ions. And their velocity, or we can say speed, becomes instantaneously zero. And then after again in another direction, it is accelerated. And again when the collision takes place, its speed becomes zero. So resultantly, it moves in the opposite direction of the electric field. So we say here the average drift speed is acquired by electrons. Clear? C. If the electron drift speed is so small and the electrons charge is small, how can we still obtain large amount of current in a conductor? We get large amount of conductor in the conductor, large amount of current in the conductor because the number of electrons, that is tremendous large one, or in other words we can say the number density of electrons in the conductor, that is tremendous large one. D. When electrons drift in a metal from lower to higher potential, does it mean that all the free electrons of the metal are moving in the same direction? No. If any electron suffer the head-on collision with ion, then it rebounds. So not necessarily all the electrons are moving in the same direction. E. Are the paths of electron straight line between the successive collision with the positive ions of the metal in the absence of electric field? And 2. Presence of electric field. Yes, in the absence of electric field, the path will be a straight line. But in the presence of electric field, electrons experience the force. And when the force is acting on the particle, the path that will be curved one. In general, that type of path is followed by the particle. Clear?